I know where there's some, right here in the hall, clerk.
No, Molly, not in there. I have enough.
One of these days.
What we want to do is measure from the antenna. Well, let me show you the new schematic, because this used to go straight from the antenna connection, vein stock, to this RC, this resonant circuit right here. It doesn't any longer. With this release of the radio, it goes through this wave trap right here, then to that 10K resistor. So the wave trap is this guy right here, and the antenna is back here, comes through, I can see the wire here, to this point right here on the wave trap. Goes through the wave trap. The wave trap should be a zero DC resistance path, because it's a coil with a capacitor across it, so we should get very low resistance. And we get 20 ohms. It doesn't say in the schematic what the wave trap should be, but 20 ohms is pretty low. Then it goes from there to through the wave trap to this point right here, where the 10K resistor and a coil are in parallel. And that's right up here. This, you can follow this red wire. There's the 10K resistor. I can go across the resistor and measure that resistance, and it'll be way less than 10K because there's a coil in there. So it'll be almost 11 ohms, and the schematic calls for 11 ohms. So we know we're good to there. We know we're good across this coil. Now we should be able to measure from that point to ground and see almost no resistance. Let's see, what's it say? Oh, 0.7 ohms. Should be able to measure from here to ground and see this 0.7 ohms. And if I just touch ground anywhere, it's open. So it's not working. What's not working? Well, that little coil, that little tickler coil, either the connection to it or the coil itself has broken. And that's this wire right here, from the band switch down to this connection on this coil. So something is open between here and ground. And that means taking this out, which I'm loath to do, but I have no choice. For the radio to work properly, this has to come out, and I have to see if I can see where the connection, the ground connection, which is right here on this radio, is not going through this little coil. And it probably isn't even very many lines. But we've got to get this out of here to see what it looks like. So we'll start there. I'll desolder this resistor and shift that bakelite box a little. I probably don't have to. Then desolder all the wires connecting to it. Then we'll pull this up out of here, see what it looks like. Okay, I've got everything desoldered in there. I'd like to move this cap over a bit, if it will. Oh, just a bit. Okay. This should come out of here, he said. Okay, there we are. This is the RF coil, the antenna coil. Coils, I should say. The bulk of it, all of this, is this winding right here. It's 11 ohm primary winding. The little bit, this 0.7 that we're interested in is under this tape right here, I presume. So the first thing I'm going to do is sit down and figure out which of these pins, based on its location and where this wire hooked up. Yeah, it's going to be one of these two, and I'll take a little tape off here and see if I can see anything. This right here looks like it's had a glob of solder put on it at one point in the past. I wonder if that's where the break was, or if there was a break prior. Here's a little bit of giveaway green right there, so that's corroding. There's some more patches of green in here. That means corrosion. Here's the coil, and it looks to me like this coil stopped working in the same place before because there's a glob of solder right there. And it's kind of surprising there are no globs of solder anyplace else. And that one's kind of sloppy looking. And this is the pin that the coil that we're interested in connects to, right here. So that's where it's open. And I think what I'm going to do is put a dot of resin on there, soldering resin, rosin, and see if I can reflow that. Reflow is just a fancy word for put my soldering iron on there and see if it'll reconnect itself. That wire you can see right there, I presume, is the one that's come loose, or is corroded through, or whatever. So there's a little dab of what brand is this? I don't know, water soluble flux. That's all I know. All I know is what I read on the box. So let me get the iron on there for a minute. And maybe we'll get lucky and reconnect. All the solder came off on the soldering iron. Okay. Nope. Afraid not. I still have it open there. I think I'll get out my magnifying glasses and see if I can see a break right there. It would be really handy if it were just right there, because then the wire I want to attach to is right there, and that would be an easy connection. It looks like this winding, it's a very small coil on the schematic running to ground, and it looks like it's about 5 or 6 windings right here. These 5 or 6 windings right here. This is the primary, and then there are 5 or 6 windings round on top of it here. I might tackle that. I might try to see if I could do that. I've got some number 34 wire, which is about the right size. So, but first let me look at this under some high magnification and see if I can see where it is actually broken. Okay, what I've done is the globus solder that was right there didn't do any good. There's continuity. The wire runs from this pin up to here and then cuts back this way. So I exposed some copper right there, and I have continuity from this point to here. So this end of the winding is okay. So this is the signal end. The ground end is right here. And keep in mind that the coil we're interested in are these 5 or 6 windings right here. And that's where one of those green dots is. Don't know if you can see it, but it's right there. So the other place to look is to excavate here and make sure the ground end of this coil is actually being connected to ground, this point right here. So I'll get back under the magnifying glass and clear away some of this, see if we can see a break there. I found the break. It's at the other end. You can maybe right there see the end of it. Here's the end of it. I couldn't find the loose end. It's under here somewhere. But I think what I'm going to do is make note of which way it wraps, and it wraps around this way 5 times and then comes out and connects to ground here. So I'm going to see if I can find that little spool with number 34 magnet wire that I've got and see if I can take this off and rewrap it with 5 turns. Even I should be able to do that. Well, it turns out I did not have any magnet wire. I've had to order some. So rather than hold up things, I got the antenna coil out of the parts radio. And I know I'm very lucky to have a parts radio in the first place, but that's the way it goes. And this one works. This one, there are no green spots on it, and this secondary, this little secondary that we've been chasing down right here is in good shape. So we'll put this one in, and we'll take it to the next step. All right, it's back in, or it's in. I think I forgot to solder one lead. That's what I think. I always wonder if I did it correctly. I follow the schematic and I make drawings and I take lots of pictures, and I'm still in doubt whenever I do something like this. But that's the nature of me. Now I'll pull up the pictures and go back and check for myself and make sure that I believe everything is correct, and then we can move on. One thing we can do to kind of confirm where we are is we can check the continuity through this primary. Keep in mind that if you hook a ohm meter to the antenna and to ground, you should see the value of the wave trap coil, which isn't listed here, and the DC resistance of this primary, which is 11 ohms, across a 10K resistor, and then the 0.7 ohms for this little chunk that was not working in the other transformer, and finally the ground. And the quickest way is to just hook one end of the probe to the antenna terminal and the other end to ground, and it squeaks. So if we do a real measurement of DC resistance, we're getting 32 ohms, which is probably about right. Here's 11, so 11.7, 12 ohms there. Who knows what here? Now, one thing we can do to validate whether this is still all working is by turning the band switch to police band. That will short out this coil here, and we should see a drop in resistance. And we do, 21 ohms. So the band switch is working, the antenna coil is working as far as I can see, and we're ready to apply power again and see if we get any radio station noise. So let's do that. What I will do to make sure that everything is back the way it was, or at least in terms of voltages, is I'll connect to the plate of the 6A7 again, which is pin 2, and then we can make sure that we have that appropriate plate voltage, the appropriate plate voltage on there. Should be there to ground. Okay, we're still on dim bulb. Voltage, I'll run it back down to 0. Radio is on. Volume is all the way up. This is set to the plate of the 6A7 tube, and we are ready to bring on some voltage. Turn on the Tipton device. Okay, we're at 58 volts. The dim bulb is not lit. Run up to 75. Let me make sure that oh, rats. One of the jumpers on the speaker came loose, and without that, ain't nothing gonna happen. Okay, that's back in where it belongs. Turn this back down. That's on. Okay. So up to 50 volts. 50 volts coming into the radio. 62. Turn the radio on. Now we're getting some plate voltage on the 6A7 tube. Ultimately, we should have about 250 volts there, but yeah, now the caps are charging. Run the Tipton or the Variac up to 75, give or take. And at 75 volts, we're pulling 200 milliamps. Dim bulb isn't lit. We've got 204 volts on the plate of the 6A7. No sound yet out of the speaker. Go up to 100 volts. Yeah, now the speaker is starting to sound like a speaker. Okay. $248 volts on the plate at about 100 going in. So that all appears to be okay. Haven't broken anything yet. There's no smoke. A crackle from me hitting the speaker wires. All right. There. Now it's my finger touching the antenna terminal. So that's a good sign. That means a finger touch right here. Sorry. A finger touch right here is inducing some noise into this, and it's coming out the other end. So that's a good sign. All right, we got our radio. I'm turning the tuning condenser, you might have guessed. Okay. All right, success. Well, the Philco is back to life. It probably needs a long wire antenna, first of all, more than my finger. It needs, it probably needs alignment. I need to figure out whether I want to replace the, let me turn this camera a bit. I need to figure out whether I want to replace the caps in this box, and that means I have to look at what they're doing and see if I think they're critical enough, and they may be. So the caps in this box are an issue, or potential issue. Alignment setup, I've monkeyed with almost everything back in the back of the radio here that has to do with alignment. Monkeyed with as in touched and prodded and poked. But that's okay. So power is an issue, or could be an issue. this bank of caps right here, an alignment, and it may be a working Philco 60B radio. How cool is that? All right, that's it for this video. Next time I will have made up my mind about some of this stuff, and we'll talk about how to finish up on the chassis. See you then.